Let's go through the same process again for letter C. So we look at this and we see that we have a carbon and hydrogen compound reacting with oxygen. That should be an immediate tip-off to you that this type of reaction is a combustion. And combustions are easy to predict the products of because they always have the same products. The products of a combustion reaction are always carbon dioxide and water. So that part's easy. This part's always going to be the same. Now, balancing a combustion reaction is a little bit more tricky. The way we go about doing it is you always want to go in the order CHO. You always want to go carbon, then hydrogen, then oxygen. So, balancing carbon first, we have 3 carbons over here and only 1 here. So the way to make that right is to put a 3 here. Now we have 3 carbons on this side. That balances carbon. Now let's take a look at hydrogen. We have 8 hydrogens over here and only 2 coming from water. So in order to make that work, we'll put a 4 here. 4 times 2 hydrogens gives us 8 hydrogens coming from water. So that balances hydrogen. 8 hydrogens, 8 hydrogens. Now, we need to take a look at oxygen. And to do that, we need to total how many oxygens are coming both from carbon dioxide and water. So here, we have 3 carbon dioxide molecules. Each carbon dioxide molecule has 2 oxygens. So you have a total of 6 oxygens over here. And over here, we have 4 times 1 oxygen, 4 water molecules. Each water molecule contains 1 oxygen. So we have a total of 4 oxygens over here. That gives us a total of 10 oxygens in the product side. Now, in order to make 10 oxygens in the reactant side, the way we would do that is we would multiply O2 by 5. We have 5 oxygen molecules on this side. So this equation now says that 1 molecule of propane combines with 5 molecules of oxygen to produce 3 molecules of CO2 and 4 molecules of H2O. We know that this is balanced. The carbon, hydrogen, and oxygen are all balanced, so this is complete. Let's do the remaining 2. Here, we look at this equation in part D, and we want to identify the reaction type. So we have 2 ionic compounds. Aluminum is a metal, chlorine is a nonmetal, calcium is a metal, carbonate is a negative ion, a combination of nonmetals. So our reaction type here, since we have 2 ionic compounds, is going to be a double replacement. Now what happens in a double replacement is the positive ions switch places. So calcium comes and joins chlorine, and aluminum comes and joins carbonate. So we know that our products will be Al with carbonate, CO3, and calcium with chlorine. Now, again, we need to use the drop and swap method to figure out what the chemical formula of aluminum carbonate is going to be. All step 2 did was predict the names of our chemical products. Aluminum carbonate, calcium chloride. It did not predict what the chemical formulas that attach to those names are. We have to do that ourselves. So, aluminum gets a 3+ charge, carbonate gets a 2- charge. Dropping and swapping, our chemical formula for aluminum carbonate would be Al2 parentheses CO3 sub 3. We need 3 carbonates to balance out the 2 aluminums. Same here, we need to predict what calcium chloride will look like when it's combined. Calcium takes an overall charge of 2+, chlorine takes an overall charge of 1-, so we'd predict the product, we'd predict the formula of calcium chloride would be CaCl2. Now, in order to fix this, we need to find a place where this is in balance. And the place I'm going to pick is aluminum because that's the easiest one to fix. We have 2 aluminums on this side and only 1 on this side. In order to fix that, we place a 2 over here. If we're keeping track of the number of elements on each side, now we have 2 aluminums, 6 chlorines, 1 calcium, and 1 carbonate. And on this side, we have 2 aluminums, 3 carbonates, 1 calcium, and 2 chlorines. Again, we started with 1 aluminum and 3 chlorines, but once we multiply by 2, we got these numbers. So we then need to fix the chlorines. The chlorines are out of whack. We have 6 chlorines here and only 2 here, so to fix that, we'll place a 3 over here. That means we now have 3 calciums and 6 chlorines, and now our calciums are screwed up. So we need to balance with calcium over here. We have 3 here and 1 here, so we'll multiply this by 3. That gives us 3 calciums and 3 carbonates. So we check again. We have 2 aluminums, 3 carbonates, 6 chlorines, 3 calciums. We're done. So this is our balanced overall equation. Our last step here is we'll take a look at this type of reaction because it's our last new type. So we're not going to look so much at syntheses and decomposition, so we're not going to predict those in this class. I just want you to know how to do simple ionic predictions with single and double replacements, and to know what to do with combustions. If you do that, you're fine. So if we look at this, half reaction of just the reactants, we see that we have H2SO4 and CaOH2. So we have sulfuric acid and calcium hydroxide. We have a positive ion with a negative ion, a positive ion with a negative ion, Ca2 plus with OH minus. So we're going to predict that these are going to swap like a double replacement. But this isn't just a normal double replacement, this is an acid combining with a base, so we know that this is a neutralization. As far as predicting reaction products go, a neutralization behaves exactly the same as a double replacement reaction. H will go with OH, and calcium will go with sulfate. So we know our products are H with OH and calcium with SO4. So we know what our products are. We need to predict what the formulas are. We have H plus with OH minus, so our product would be HOH, 1H, 1OH. This is water. We know our other product is going to be calcium with a 2 plus charge, plus sulfate with a 2 minus charge. So these charges already balance. We could drop and swap and then reduce, or we could just see that our product is going to be CaSO4 because these charges are balanced, and that's the whole point of doing the drop and swap anyway. So we try to find a place where we have an imbalance. So I see that we have 2 hydrogens here and only 2 H pluses here and only 1 H plus over here. So the way we fix that is put a 2 here, and now all of a sudden our reaction is balanced. We have 2 hydrogens, 2 hydroxides, 2 hydroxides, 1 calcium, 1 sulfate, 1 sulfate. So that goes through the product of predicting reaction products, how we go about the process of predicting reaction products, and how we go about doing that. I hope this overall helps. It takes a little patience to go through this, especially when you're inexperienced and you have to look each of these things up on the periodic table. You don't have them memorized. It takes time. I understand that. But being able to do this definitely will help you later on when we get into the lab and when we're looking at chemicals like we did with our double replacement reactions last week, and will allow you to make predictions about what's going to happen. And even more than that, how much product will be produced. So I hope this helps. Let me know if it doesn't. Leave me comments. Thank you very much. Bye.